Hello, good morning, one and all. So, are you getting my voice? Yes, in last lecture we have started the chapter number 7. So, the implementation of OMT. So, the points we have covered, two, 3 points we have covered earlier in this from this chapter. So, the remaining points we will cover today, and we will finish the chapter number 7 also. So, we'll just take the review of what we have covered earlier. So, after that, we will start our the point. So the name of the chapter is the implementation of OMT. So again, this is the syllabus points, the use of programming language and database system. Again, the object-oriented style, feature of object-oriented languages, and applications of OMT like object diagram compiler, computer animation, case study of hotel management system, and again the course management system. So up to the object diagram compiler, we have covered the this chapter, and today we will see the computer animation and case study of hotel management system and course management system. Okay, so the introduction point we have covered the implementation using a programming language and implementation using a database system. This also we have covered, and object oriented style. So in that object oriented style we have covered 4 categories. So the 4 categories are that the reusability, extensibility, robustness, programming in the large. Again, in depth, we have studied about the reusability. That is, in case of the reusability, we have studied that kinds of reusability, style rules for reusability, again, the using inheritance. So, all these points we have covered earlier. And after this, we have studied the programming in the large. This also point we have covered. That is about the class description, method description, operation description. After that, we saw that object-oriented language features. So there are total 12 language features are there. The multiple inheritance, class library, again the efficiency, strong typing versus weak typing, memory management, encapsulation, packaging, development environment, metadata, parameterized classes, assertions and constraints, and data persistence. Okay. This also we have studied in detail, in depth we have seen that. Again after that we saw that object diagram compiler. So in case of the object diagram compiler, we have studied what is the background of this object diagram compiler. Again the problem statement, again the analysis, the system design, again object design, implementation, and again lessons learned. Okay. All these points we have covered under the object diagram compiler. So in depth we have studied about this. object diagram compiler. Now the next point is that, see, just we will see the what we have covered in this object diagram compiler here. So what lesson we have learned from the object diagram compiler here. So this is about the one slide of the what we have covered in case of the object diagram compiler here. Okay. So here you can see that we draw the following conclusions from our experiences in developing the object diagram compiler. So what was our experience while developing the object diagram compiler? That is mentioned here. That is stick to the object association paradigm and avoid the temptation to use stacks, pointers, and other data structures. So in most cases, the use of associations eliminates the need for complex data structure. See, this is the advantage of the relationships. Okay. So in most cases, the use of associations is going to eliminate the need for complex data structures here. And use of a limited number of paradigms and a rich library of container classes greatly cut the number of bugs and increased our software development productivity. So automatically it is going to increase the software development productivity. And when making enhancements, don't just patch the design, rethink the analysis. Wherever we violated this rule, we wasted time and made errors. We need to rethink about while making the enhancement and again the analysis, and think through the consequences enhancement deeply and not superficially. We need to think about the deeply, and batch software is much easier to write than interactive software. So the batch software does not need to contend with user interface and dialog considerations. Okay, these are the some conclusions we have made out from the object diagram compiler here. Now we'll see the next point is that the computer animation. So what is the computer animation? See, as a being an computer engineer, we are already familiar with what is the computer animation. So what is the meaning of the animate? Means we insert the lives, okay, in the object, that is called as the animation. Means to animate the object. Okay. This computer animation system creates sequences of images which when shown one after the other create the illusion of motion. Okay, there are some channels are there, okay, that is cartoon channels. Okay, these are the cartoon channels are the examples of the computer animation. So the computer animation system, it is going to create the sequences of images which when shown one after the other create the illusion of motion. Okay. And the computer animation systems require an extensible design so that new applications and new graphics hardware can be easily added. Okay. Means the computer animation system, it requires the extensible design. Okay. It requires some softwares, again the hardwares we require. Okay. Means for creating the any animated movie, for that purpose we are in need of the animation softwares for the animation, and again the hardwares also we require for that. Okay. And this part describes the three-dimensional computer animation system. Okay, this is the 3D computer animation system is there. The system Oscar, the object-oriented scene animator, produces high-quality film and video sequences of the results of scientific and engineering calculations and experiments. Oscar automates the creation, control, and management of 3D computer generated animation sequences. Okay? And using an object oriented script language as its user interface, Oscar controls analysis, modeling, rendering, display, and filming. Means analysis, modeling, rendering, display, and filming. All these are the characteristics of the computer animation here. And interfaces have been developed for scientific analysis programs in the areas of modeling, robotics, mechanisms analysis, and fluid mechanics. And the object-oriented design has produced a system that lends itself to interfacing with existing and future applications. The Oscar application demonstrates how an object-oriented design can be successfully implemented with non-object-oriented languages. And Oscar is written in C using an object-oriented development environment that includes macros and runtime support for inheritance, instancing, and message passing. And Oscar includes an interpreter that permits user to create instances from the animation classes in the system and to control these instances by sending messages. And the background of this computer animation is that the Oscar is the result of a research started in 1984 on the application of object-oriented technology to industrial applications. So it was started in the 1984, and because we expected computer graphics systems to increase performance, dramatically throughout the 1980s, and we proposed developing a 3D computer graphics animation system that would allow scientists and engineers to study the results of their experiments and analysis. And at the time, no C-based object-oriented systems were generally available, so we developed our own object-oriented interpreter to support the animation research. This interpreter called LYMB includes a runtime library for creating objects and communicating with them using commands and runtime message passing. The interpreter has no dependencies on computer animation, so the animation knowledge is held with the animation specific classes. So what is the animation process here? So how you are going to implement the animation here? So the animation, that is the Oscar, simulates the steps in the traditional manual animation process, and as in all disciplines, animation has its own terminology. Okay. Now in the today's world is the computer world, so everywhere we are going to use the animation. So while giving the training also we are going to use the animation. Okay. And we briefly for showing the demos. Okay, for that purpose also we require the animation there. Without the animation, it is not possible to have. Okay. And we briefly describe the animation process, defining enough jargon for the reader to understand the Oscar system. The user of a computer animation system acts as the producer. Okay. The user of a computer animation system, it acts as the producer, writer, and director of the final animation sequence. Okay. Mean the user of a computer animation system, it acts as the producer, writer, and director of the final animation sequence. The sequence may be played back on a computer graphics, okay, terminal, or recorded onto movie film or a video tape. The producer manages the overall film production, keeping schedules, assigning tasks, and organizing resources. So the producer manages the overall film production, keeping schedules, and assigning tasks and organizing resources. So very important, note this. The producer is going to manage all the overall film production, that is keeping schedules, assigning tasks, and organizing resources. The writer creates a script based on the requirements of the customer. The director controls the animation, positioning, the props and actors, cameras, and lights. The animation process proceeds as follows. The first of all, writing the story. The writer working with the customer develops writing is an artistic process and is difficult to assist with the computer. The actors may include animate objects. Okay. Second step, a storyboard. A storyboard is a graphic synopsis of the animation, illustrating the appearance of the animation and the flow of the story. The storyboard contains a representative drawing for each major point in the story. The art director normally produces the storyboard. And the script is that the script contains the detailed positioning and movement of the actors, cameras, and lights in the animation. Some computer animation systems provide scripting languages since the script may change over the course of the production. A good language allows the script to be easily modified when minor animation changes are required. So this is about the steps, that is the story, and again the storyboard, script, and again the fourth one is the simulation. Okay. We'll see that. What is the simulation? The simulation is nothing but it experiments, and the simulations often provide the motions of the animation for scientific applications. Okay. For scientific applications, we require the motions, means to move the object, that is the 2D object, and again the 3D object. Okay. The one thing I want to tell you, that suppose you learn in the computer graphics, okay, in your second year, and so there we have studied about the translation and again the transformation. So what was that? In the transformation we have studied about your scaling factor, again the rotation, okay, again the reflection. Yeah, all these points we've studied that. So what is the use of that transformation? The use of that transformation is the only to provide or to make the a computer animation. We remember this one. So the scientists and engineers familiar with the application domain set up and execute these simulations, and simulations can be computation intensive. And the fifth one is that it models each props and actor in an animation must have a geometric model that describes its appearance. And this model is translated during the rendering process from a mathematical description into a portion of a 2D image. And the sixth one is the preview. Before committing the animation sequence to film, a fast preview of the animation helps establish critical timing and the overall look of the final product. Producing high quality film output is usually costly, so changes to the simulation should be made as early as possible. And the seven is the render. So the rendering produces shaded images for later display by applying algorithms to the geometric model, surface properties, and lighting. So this is called as the rendering. The render operation corresponds to the assembling a single frame of a conventional animation, rendering realistic effects such as multiple light sources, texture, shadows, and translucencies and refraction can be computation intensive. So the recording, the 8 point is about the recording. After rendering, the images are recorded on either film or video, one frame at a time. This is about the steps included in the animation process. You just remember all these steps here. And the first one is the story, second is the storyboard, third one is the script, fourth one is the simulation, fifth one is the models, sixth one is the preview, seventh one is the render, seventh one is the render, and again the eighth one is the recording. Okay, there are total eight animation processes are there. Okay, and a typical animation application is a three-dimensional molecular modeling. And first, batch simulation is run on a super computer to computer the position of each atom in a vibrating molecule over a period of time. So it's about the animation process. So the typical animation application is the three-dimensional molecular modeling. And first, a batch simulation is run on a supercomputer to compute the position of each atom in a vibrating molecule over a period of time. The actors are the atoms in the molecules and their chemical bonds. The animator prepares a script viewing the molecule from interesting angles, and rapid previewing is essential because it is hard to choose the right viewing angles without seeing the results. The final animation is run at full resolution and a film is produced, actually exposing a film of several minutes. Duration can take a full day of computer time. So what is the problem statement in case of the computer animation? So the goal of the graphics animation system is to provide an automated system for the efficient creation, control and management of 3D computer generated animation sequences. The system provides facilities to record animation sequences on 16 film or a video, and the system also provides interfaces between diverse simulation, modeling, and rendering systems. And it are realizing that the application of computer animation is broad, so the system must adapt to new applications with a minimal amount of new software. So the following requirements were derived from knowledge of the conventional movie making process and the scientific and engineering analysis process. The movie animation metaphor used is that of stop frame animation. So in a stop frame animation system, frames are recorded one at a time. So the movie animation metaphor used is that of stop frame animation. In a stop frame animation system, frames are recorded one at a time. So all participants in the animation are changed slightly and another frame is exposed. The user input consists of text files that contain animation scripts. Scripts can reference a library of complex actions as well as define new actions. And the scripting language serves as a base for animation description and documentation of an animation. So the actors are the active participants in the animation. They have shape, position, orientation, and appearance properties such as color and texture. For example, in a planetary exploration, animation actors would include planets, rings, satellites, rockets, stars, and the sun. The specification of actor motions must be flexible enough to allow rotations and scaling about arbitrary axes and origins. The visibility of individual actors must also be controllable. Often it is useful to group actors together, so the system must provide a mechanism to allow actors to be collected and controlled all together. The geometry of an actor is kept in a geometric model. So it models range from rigid motions of simple geometric shapes to complicated deformations of complex objects. Since modeling is a complicated and a tedious task, the system must be able to use models that already exist, and it also users may have invested large amounts of training in the use of specific modelers, and modelers should quickly produce low resolution models during previewing so that the computation time to produce a high resolution model is only be required for the detailed film. Okay. And all animation is viewed through a camera. Multiple cameras can exist, but only one is active in a scene at one time. So the user can place the camera in the environment and control its aim and orientation. Different camera movement effects like panning, zooming, and tracking are required. So the multiple lights can be used to illuminate the animation. So the lights can be turned on and off, and their intensity can be controlled. So the lights also have geometries spherical, cylindrical, point, or flat. The engineers and scientists who use the system will rely on their own analysis programs to provide much of the physics of the animation. Therefore, the animation system must provide a way to interface to these external programs. These programs should not be modified just to interface with the animation system. So the interface burden must be borne by the animation system. The system must provide a facility to track completion of frames and where they reside. A frame is one image in an animation sequence, uh, and a frame can be built from one rendered frame or a combination of rendered frames. And a post-production capability allows the user to recall frames, combine them with other frames, and manipulate them on a residing device. It is too time consuming to specify the incremental motion of each actor in an animation for each frame. So the system must provide a way to move objects along easily specified paths. And keyframing is an animation technique that lets an animator specify complex motion by giving a few keyframes and letting a junior animator fill in the intervening frames. A computerized animation system should have a keyframing capability in which the system interpolates the animation. And this is about the analysis. In the case of the analysis, again we can do for the analysis about the object model, dynamic model, and again the functional model here. So what is the object model here? So in case of the object model, now we extract objects from the requirements and our knowledge of computer animation and computer graphics here. Notice that the terminology from the problem statement is used in the object model. Okay. And many of the properties we specify for the objects come from our intuitive feeling for what an object should look like and how it should behave. So identifying the object classes, we start by listing of candidates object classes. First one is the actor, again the camera, light, again the scene, cue, renderer, again the sequence, again a frame. Okay, these are the some object classes. Again, the actors are the participants in our animation, and our actors can represent a variety of objects we wish to model. So we have tried to determine what properties are important to all actors regardless of the application. So in a finite element analysis, an actor could be an element mesh of a turbine blade, and for molecular modeling both atoms and bonds are actors. And cues, the cues control the actors, cameras and lights in the animation. And cues are temporal objects changing the state of the animation with time. And each cue is a series of events. For example, a cue might tell a ball to start rolling across the room or pan a camera across the stage. And anytime dependent action can be affected by a cue. And we follow four classes through analysis: actors, cues, renders, and scenes. The renderers produce the individual frames in the animation, and rendering is still an active research area in computer graphics. So we must take care not to restrict ourselves to a particular renderer, such as a scanline, a ray trace, a radiosity, or wireframe. And the challenge is to characterize the properties of renderers to have. And the renderer is an abstract class meant to be overridden by subclasses. And we follow four classes through analysis: actors, cues, identifying associations and attributes. And here we define associations and attributes in the model. So the each actor has a model that describes its geometry, and modeling is an active research area, and there is no one modeling technique that can be used in all situations. Also, the requirements state that existing modelers have to be supported. So model is an open-ended abstract class. And queues are time sensitive. Each queue has a time interval during which it is active, and usually the user wants to do something special when an interval is entered and when it is excited. We call actions that should be executed at the start of the interval start actions, and those that should be executed when the interval expires and end actions. So while a queue is active, it executes tick actions at the time resolution of its enclosing scene. So here is the object model for Oscar system. So the sequencer, action, transformable object, scene, renderer, light, camera, actor. So you all, I will give the 5 minutes for time for this one. You all take the diagram for this. That is the object model for Oscar system. You just draw the diagram for this. So the next is about the dynamic model. So the dynamic model is that the state model for scene. So here you can see that the start time, that is the do start actions, and the tick and end do end actions. Okay, this is the dynamic model, state model for the queue. So the dynamics of an animation are specified by a scene, which encapsulates a series of user-defined events. Figure second and third show the dynamic model for scene and queue. A scene repeatedly enters the tick state, each time incrementing the current time and sending tick events to its queue and render events to its renders. And queue is similar, but it receives tick events from the scene. And this is about the functional model. The functional model is about the most computation intensive functional model is that for the renderer is shown in figure 4. Okay. The camera, actors, and again the lights. So the camera parameters, viewpoint polygons, transform polygons to a viewpoint, hidden surface removal, quantize onto view plane pixels, again the frame, surface shading and smoothing, ray trace lights to polygons. Okay, the camera, actors, lights. Okay, these are the how we are going to transfer the information from one to other. Okay, this considers in case of the functional model here. And the last one is the system design. So in case of the system design, again we have the some different points, that is the subsystems, and again the concurrency and control, data formats, and trade-offs. Okay. So the system architecture groups objects in the system according to the steps in the animation process, and the anthropomorphic flavor of the model descriptions helps to maintain the correspondence with the animation process. The interactive script generator permits the user to generate scripts using a graphical interface with the script powerful, easy to use interpreter and a library of useful animation operations. We avoid the need to provide a special animation language, and simulators are the external analysis programs. Typically, simulators are run separately from the animation process. They provide the physics for the animation sequences. Often, a simulator controls a complete animation with Oscar doing little more than positioning a camera and turning on a light. As the modelers are created the geometrics for actors, and they are loosely related to renderers since some renderers can only process models from specific modelers, and often the models are made from polygons, but the system must be able to handle other modeling primitives. And the frame editor objects do post production editing, combining frames and creating special effects, and like wipes, dissolves, and fades. A frame clerk tracks where each frame came from and where it is stored. It is a data store accessed by other modules. The renderers take actor, camera, and light information to produce a single frame of animation, and the external renderers run in a batch mode, producing their images from command files created by Oscar. Other renderers are built within the animation system itself, but all renderers respond to the same protocol. The recorder objects take finished frames and commit them to fill or video. They also respond to a specific recording protocol, converting these messages into device-specific control functions. the concurrency and control. Oscar is run as a sequential batch job, so concurrency is not an issue, nor as allocation of tasks to the processors. And control is implemented procedurally by explicitly sending messages to objects within the iterative loop simulating scenes and data formats. The scripts are written as sequences of operations in the object-oriented interpreter language rather than in special format. The format of the frame clerk must be given, but we omitted here. The format of the simulators, modelers, and renderers is specified by their suppliers and is beyond our control, so we must accept them as they are. So the trade-offs. So the director and the interpretive language must be easy to use and flexible, but they will not consume much runtime as most of the execution time is spent in predefined simulators, modelers, and renderers. Thus, we choose to make the interpretive language highly symbolic. Operations are encoded as text strings which are interpreted at runtime using an explicit search of the class hierarchy for methods. Operands are passed using variable length argument, lists and text keywords for flexibility. Setup operations use several levels of indirection for flexibility, and we also incorporated several debugging aids. And the efficiency of the director is less than 50% but does not matter because the director consumes a small portion of the overall Oscar execution time. So how the object design could be? During object design, we begin to shift our focus from the external requirements to the computer implementation. We extend the object models we derived during analysis to include associations and attributes that objects require for internal processing. Most of the design, however, is a simple and direct implementation of the analysis model. Okay. So the implementation part of this computer animation is that so Oscar is implemented using an object-oriented interpreter based on the C language. The interpreter implements creation of classes and objects, single inheritance, and operations coded as text strings. Its syntax is similar to Smalltalk with some extensions, and the user interface consists of a parser that interprets operations of the form. So the object name message sequence and message sequence consists of messages with optional arguments. The suffix of the message determines whether a message requires arguments. The following suffixes illustrate message semantics. Question mark, it requests the value of an instance variable equal to sets an instance variable, colon has arguments but does not set an instance variable, at defines an index, plus minus slash and star terminate arithmetic operations. Okay. And messages to one object can be concatenated on a statement. A typical statement is actor new colon a box position equal to 0 comma 5 comma 0. So the rotate underscore x colon 30 color is equal to 101 on. The actor is a class that responds to the new message by creating an instance of itself with the name a box. The classes, when they receive new messages, return a pointer to the new instance that will receive the rest of the messages in the statement T. His new actor receives the position equal to a message, causing its position instance variable to be set to 0, 5, 0. So the remaining messages rotate a box 30 degrees about its x-axis and set its color to magenta. So the red equal to 1, green equal to 0, and again the blue equal to 1, and turn it on. The system's knowledge of the problem domain, here computer animation, is kept with yum, the classes, and not in the language. Okay, this is the simple code of how to create the animation. Okay, what we covered from this computer animation here. The Oscar made its first film in December of 1984 when it consisted of 25 classes, including actors, cameras, lights, cues, and again the renderers. And since its initial implementation, Oscar has gone to contain over 90 classes. Thus, over half the classes share code with other classes. And during this project, we made several observations like that. Applying object modeling to animation produces a natural user interface with terminology that is familiar to experts in the application domain. The abstraction step of the design is critical and requires the most effort. The object-oriented approach partitions a complex system into a manageable pieces, and the system is less fragile than others have written. We make changes and additions without fear of breaking Oscar. Okay, this is about the computer animation. And the last and again the hotel management system. Okay, that part also we will finish today. So this is about the CMS. So about the course management system, so shortly it is called as the CMS, that is a course management system. So the CMS is a collection of software tools providing an online environment for course interactions. And course means you are going to learn the different subjects. Okay, that is subject is called as the course. The CMS typically includes a variety of online tools and environments such as an area for faculty posting of class materials such as course syllabus and handouts, an area for student posting of papers and other assignments, a gradebook where faculty can record grades and each student can view his or her grades, an integrated email tool allowing participants to send announcement, email messages to the entire class or to a subset of the entire class, a chat tool allowing synchronous communication among class participants, a threaded discussion board allowing asynchronous communication among participants. And in addition to this, a CMS is typically integrated with other databases in the university so that students enrolled in a particular course are automatically registered in the CMS as participants in that course. The decision to use the CMS in a traditional face-to-face course has implications for course design that often go unnoticed by instructors in their initial use of such systems. This module lists technical and pedagogical tips that instructors should consider as they place materials into a CMS. While it is intended primarily for instructors who are using the CMS for the first time, instructors who have already used as a CMS in other courses might benefit by using these tips as a checklist. Okay. This is a teaching learning environment, that is CMS. It's about the course management system. And after this course management system, we have the hotel management system. Okay, so the hotel management system we will see that in detail. So this is about the hotel management system that we will see in detail. So the very interesting points are there in the hotel management system. So this is about the admin. So what does the admin in case of the hotel management system? So the manage rooms, manage packages, manage cancellation, manage advertiser, manage client, manage reports, and manage feedback. So what does the client? So the client it view hotel information, it manage a profile, select a package, room booking, payment, again the cancellation, again the give feedback. So what does the visitors? So visitor is going to view the website and registration, the system flowchart. So what is the system flowchart? So this is the system flowchart. So I would so here you can see the system flowchart. So first of all, the start again the view site is registered. That is no. Then go for the registration. If yes, then go for the login. If you are the admin, then you go for the admin. If you are not admin, then you go for the visitor side. Okay. So again, if you are admin, then you can manage the rooms, package, cancellation, advertise, client reports, again the feedback. If whether you are the visitor or you are the client, then you can go for the view hotel information, manage profile, select package, room booking, payment, cancellation, and again the view feedback. So finally, after having your work, then you can log out and again you can stop. Okay. So I'll give the 2 minutes time here. You just draw this diagram. This diagram is very important. Many times they ask the question on this hotel management system. Now here you can see that the UML diagrams for the hotel management system. So this is the UML diagram for the hotel management system, and this is for the admin. So hotel management admin side, it manages the room, Manage package, again it is manage cancellation, and manage advertiser, manage client, and again the manage reports, and again the manage feedback. Okay, and this is about the client side. So what does the client here? Hotel management client side. View hotel information. He manages this is the profile. Again he manages select package, room booking, the payment, cancellation, and again give feedback. Again the visitor. So hotel management visitor side. So view website. Again the registration. Again what is the activity diagram here? So this is the activity diagram. So what does in case of the activity diagram here? So the activity diagram for the admin. Okay. This is the activity diagram for the admin side here. So start the first of all, yes, we have the login, then you can go for the login directly if valid. If otherwise not, then again you can go for the login with correct credentials. Okay, and again after that we have the manage the rooms, manage packages, cancellation, advertiser, client reports, and again the feedback. So this is the activity diagram for admin here. You just observe here the diagram, the activity for admin here. So what he is going to do with the all the functions here. So how step by step he is going to perform his activity. Again, this is the activity diagram for client here. So what does the client with respect to the activity here? Is for the client is registered, then go for the direct login. And if is not registered, then go for the registration process. Then login, after logging, it has the following functions. View hotel information, manage profile, select package, room booking, payment, again the cancellation, again the give feedback. Okay, all these are the functions for the client here. So that is why this diagram is called as the activity diagram for client here. So this diagram also we can observe this diagram here. So how the diagram can be drawn. So all these activity diagram, UML diagrams we studied in the chapter number 5 and 6. Okay, by the taking the help of that concepts directly we are seeing the examples here. These are the case studies. The first one was the course management system, and again this the second one is the hotel management system here. Okay, the diagrams are very important here. Now we can see the class diagram here. So how the class diagram can be drawn for the hotel management system here. See, this is the class diagram here. See how the class diagram is drawn here. See the sign up, registration, room category master, room details master, again the confirm payment, cancel registration, confirm package master, package category master. Okay, all these are the class. Again, these are the sign up room category master. Okay, the cancel registration. Which here you can see these are the functions here inserted: insert, update, delete, insert, update, delete, insert, update, delete. Okay, and these are the some objects, that is the user code, registration date, email ID, okay, ID proof type, ID proof number, room number, the user code, order ID, room number, date. Okay, which in that way also, see, by learning this example here, it is not limited to only they will ask on the hotel management system. Okay, but they can ask you the general example also. Okay, the general example also you can solve by learning this example. For that purpose, we should know that what is the activity diagram, what are the UML diagrams, what are the objects, what are the classes, how can you classify them. All the things we must know it. Okay. Then and then only we can go for the drawing such diagrams here. Okay. Just you can observe this diagram here very. Now the next one is the sequence diagram here. So how does the sequence diagram is we are going to define. So here you can see that these are the sequence diagram here. So first diagram is about the sequence diagram for admin side. So admin system and again the database here. What does the admin system and again the database? All are the listed step by step here. So the manage room, request for manage room, response for manage room, successfully manage room. Again the manage package, request for manage package, response for package, successfully package, manage cancellation, request for manage cancellation, response for manage cancellation successfully. So all the things we have listed here for the sequence diagram here. Okay. Up to the logout process. Okay, up to the logout process we have listed all the sequences. Third, we can see that successfully manage advertiser, then request for manage advertiser, then response for manage advertiser, and again the successfully, and manage client, then request for manage client, and again the response for manage client, again the successfully, the manage reports, request for manage reports, and response for manage reports, and the last one is successfully client. Okay, the manage feedback, again the request for feedback here, the request for feedback, and again the successfully feedback is maintained. And after having this dialog here, we can log out here, okay, as admin. Okay. Means in that way this diagram is called as the sequence diagram here. Okay. The sequence diagram for the admin side here. Again the same way the sequence diagram we have the client side here. Okay. This is the sequence diagram for the client side. It's again the client system and again the database. View hotel information, manage profile, again the select package, room booking, payment, successful. Yeah, all these are the functions of the client side here. Now here you can see the collaboration diagram. So how the collaboration diagram for admin it is we have maintained here. See, this is the collaboration diagram for the admin. So the admin side collaboration. So the collaboration diagram for admin. So the admin side collaboration diagram. System database. Okay. Admin. These are the sequences operation, authentication, operation. Acknowledge, manage rooms successfully, manage rooms. Okay. This is about the collaboration diagram for admin. And this is the collaboration diagram for client side. Okay. Again, the client side collaboration diagram is the system, database, and again the client. So these are the sequences, operation, authentication, acknowledgement, view hotel information successfully, view hotel information. Okay. So this is the client side, the collaboration diagram here. So in that way, we have studied about the hotel management system. Okay. So if you are knowing any another features in the hotel management system, just you can add for increasing our knowledge or information. Okay. Just I will open our syllabus point once again. So Polygon. So the chapter number 7, the implementation of OMT, we saw that the use of programming language and database system, then object-oriented style, feature of object-oriented languages, then applications of OMT like object diagram compiler, computer animation, and case study of hotel management system, and again the course management system. Okay, all the points we have covered from the chapter number 7 in the implementation of OMT here. Okay, this is the all the syllabus of the chapter number 7 we have finished, and I will give you that the last assignment, that is the tutorial. So still I have not given the tutorial, so I will paste the question in a tutorial in the chat box. So the eighth, draw component diagram for online examination system. Okay, that is covered. We draw component diagram for online examination system. But whatever the last tutorial is there, what is the design pattern and what makes a pattern? Describe pattern categories and relationships between patterns. Okay. This tutorial is based on the last chapter, that is the chapter number 8. So that whatever this chapter is there, I think after finishing the chapter, the 8th chapter, then we can go for the tutorial number 9 here. Okay, but till today you can finish all the 1 to 8 tutorials. See, the many of you still have not submitted the tutorials on the Google Forms, on the Google given Google Forms. Yesterday only I checked Google Forms, but still the many students are not responding. I don't know that what is the reason. After giving the many instructions, the students are not uploading the answer sheets. Why, I don't know. If you are having any personal reason or the personal problem, then you can send the message to me so that I can try to solve your problem. Okay. Our total 70 strength is there, no? But out of that 70 strength, only 15, 20, 25 students have uploaded the answer sheet. Okay. But remaining, why they are not uploading, I don't know that. Okay. You have to only try to find out your solution. Otherwise, you are having any genuine technical problem or the reason, then you can approach to me. Then I will try to resolve your problem. But my request, my humble request is that you have to upload the answer sheet. That's it. Okay. Nothing in that. Okay. And the one more thing is that once again today or tomorrow I am going to check the who have uploaded or not, and again I will give the some those who are not uploaded, their numbers I will paste in the our WhatsApp group. You can see your number there, and again you need to upload the answer sheets. Okay, this is a very important thing I am telling to you. So please take care of this one. And today we have finished all the 7 chapters, but the only one chapter is remaining, that is the 8th chapter. I think from tomorrow onwards we are having the ISCs. Okay, so we'll see that before ISC or after ISC we will plan our session. The only 2 sessions we require and we will finish our syllabus. Don't worry about that. The very easy chapter we have remained, that is the 8th chapter, and you can start to study for ISC second. Okay. And I think the IC second is based on the section second. So the fifth, sixth, and again the seventh. If we finish the eighth chapter also, then we can consider the eighth chapter. Otherwise, five, six, seven chapters. Okay. Then here, shall we stop here? Hmm? Shall we stop here? Still 10 minutes are there,
Yes,
or we can.
yes, sir.
Then I request you all, please drop your roll numbers. D- Drop your roll numbers only once. Okay. Not for the second, third, fourth time. Okay. Only once you need to write the your roll number here.